All right, we are starting Chapter 5, Section 6. And we're going to solve absolute value inequalities. Okay. So let's review a few things. All right. So first thing I want to review are compound inequalities. I want to review with you compound inequalities. Specifically, I want to review with you ands. Well, actually, I want to review with you ands. All right. When we look at an and compound inequality, all right, what does it look like? What does an and compound, like a solution to one? Or give me an example of what one might look like. Just like an inequality with a variable in it. Lily, what do you think? Sure. So there's a solution to one. I could write -3 is less than or equal to 2x plus 1, which is less than or equal to 9. Okay. So when we have an and, we have a minimum and we have a maximum, with our actual in between. All right. How about an or? What does an or look like? Someone give me an example of an or solution. L? Excellent. All right, we might have 2x plus 1 is less than 5, or 2x plus 1 is greater than 15. That's another example of an or. How many of you guys remember ands and ors? Awesome. Okay. All right, now what I want to review is I want to review absolute value equations. Because what we're doing today combines these two things together. So if I have an absolute value equation, if I have something like the absolute value of x plus 3 is equal to 7, how do we solve this? Giselle? How many of you guys agree with that? Yeah. We split. Okay. We are doing exactly the same thing, combining absolute value equations and compound inequalities. Okay? So I want you guys to kind of keep in mind that we're kind of marrying these two concepts together. Okay. So let's talk about absolute value inequalities. Okay? So absolute value inequalities. All right. So I'm going to start with just simple. If I have the absolute value of x is greater than or equal to 6. Okay. So what this means is, this means the distance x values are from 6 or from 0 is 6 spaces. Is, not is exactly, is at least 6 spaces. How many of you guys see that that's what this says? That however far that number x is away from 0, it's at least 6 spaces from 0. All right, does that make sense to you guys? Okay, so what that means is if I was to graph that, get your rulers out, I forgot to say that to you. I'm going to kind of go backwards in my explanation of this. We're going to start with the graph first, and then you're going to tell me what the inequality looks like if we write it. All right, so what numbers are 6 away from 0? What numbers are 6 away from 0? Joseph? 6 and negative 6. So 1, 2, 3, 4, 5, 6. So here's my 6. 2, 3, 4, 5, 6. Here's my negative 6. So this means all my x's that are more than at least 6 spaces away from 0. Well, that means that I have a closed dot at my positive 6. Where are all of my 6's further away from 0 direction? Which direction am I going to go? Because the distance for all my x values are at least 6 spaces away from 0. So if I start at my 6, where are all the rest of my possible x values that are at least 6 spaces away from 0? Ashley? To the right. What is the other possibility in my graph? What is the other possibility on my graph? Elle? Yeah. How many of you guys see that as the other possibility? So if I was to write that as an inequality statement, what would you write? Carmen? Not, well, first of all, what are all my x, so let's look at this one first. What are all my x values here? Aren't they less than negative 6? Excellent. How many of you guys see that? So this is the same thing as this. All right, so the absolute value of x is greater than or equal to 6. If I split, see how you have to split that. Remember, it's an absolute value. So for me to split this, it splits into both of these. My x is either going to be less than or equal to negative 6, or it's greater than or equal to positive 6. That's what that means. Yes?
So when you split, you have to switch the sign.
I'm going to show you exactly what I'm going to tell you that right now. All right. So what do you notice is my inequality symbol in my absolute value that I started with? What do you notice is my absolute value symbol? Rafaela? Yeah, that's a greater than or equal to. All right, so when we have a greater than or greater than or equal to, this is considered an OR split. You're going to do an OR split when you have a greater than or equal to. So one of them is going to look exactly the same as the original. X is greater than or equal to 6. The other one, we flipped the symbol. We flipped the greater than or equal to less than or equal to, and then we had our negative 6. So yes, Joseph, that is the pattern. One of them is going to be exactly the same. The other one is going to be the x is less than or equal to, and then that negative 6. Because my two possibilities for my absolute value of x are 6 and negative 6. All right, we already knew that. All right, but this is an or. So all my values can either be less than that negative or more than the positive. So this is an or when we have a greater than or equal to. All right, I'm not going to have you connect the graph to it. All right, but what now that means is, let's look at one that's similar to that. Let's say x is less than, the absolute value of x is less than or equal to 6. So when our absolute value is, when that inequality symbol is less than or equal to, this is always going to be an and. Our values are still negative 6 and 6. But I'm turning, when I split this, because remember, to apply the absolute value, I do have to split it. And the possibilities for whatever's in that absolute value is 6 or it's negatives, and it's negative 6. This is an and. So I'm literally just splitting this up into an and. I keep the original, and then I add on to it the same less than inequality, and then the negative 6. Yes? Yes. We're always adding the negative number onto whatever you started with. All right, and the commonality in both of these is it's always going to be a less than or equal to. With the negative number, that sign is always going to be a less than or equal to. All right. In this, it's exactly the same. It was already a less than or equal to. We just put another one of exactly the same sign on, and then the negative 6 at the end. Okay? Let's practice writing a couple of these. Who needs to see what's up there? All right, I'm just going to start with these easy ones so you understand how to write the split, and then I'm going to put expressions in those absolute values. All right, so I want you to solve. I'm not having you graph these, but when they tell you to graph, you need to graph them. You guys already know how to graph ands and ors, so I'm not going to have you do that in class. All right, so let's do the absolute value of x is less than 8. All of you solve that, please. So for here, you just need to split it. And you're just looking at that inequality symbol to determine if it's an and or an or. A less than or less than or equal to is an and. A greater than or equal to is an or. You just have to remember that. So somebody write this after we split it. Giselle? Excellent. All right, let's do another one, and then I'm going to put a expression in there. Let's do the absolute value of v is greater than or equal to 2/3. So all of you split that. All right, that's an or because it's a greater than. All right, somebody write this after the split. Rita? Excellent. How many of you guys are kind of comfortable with these splits? Okay, now let's do some with math in it. All right, so I want you guys to solve. The absolute value of x minus 5 is greater than 7. So all of you solve that. Remember, when you split these, that's applying the absolute value. So you drop the absolute value symbols. So help each other out with this if you want. When you're done, check with people by you, see if you guys got the same thing. All right, somebody split this for me. All right, Raphael, go ahead. Excellent, go ahead. Excellent. How many of you guys got that? Okay, let me give you a couple more of these. Let's do the absolute value of negative 4x minus 5 plus 3 is less than 9. So the absolute value of negative 4x minus 5, that absolute value, and then plus 3 is less than 9. Question?
Yeah.
What do you got?
So when you like split it, is that negative 4x minus 5 go into parentheses? Or is it plus 3?
Okay, so for you, this is a good question. For you guys to split these, what has to be the case? For you guys to split these, what has to be the case? Al? Yes, everything outside the absolute value has to be gone. So Joseph, I need to get rid of that plus 3 before I split it. So that absolute value part has to be completely alone on the left side. Yep. And you guys, and I'm going to put this in your notes when we're done with this, but I want to keep this in mind. The absolute value part has to be on the left, always, and the constant on the right for you to determine if you have an and or an or, okay? It doesn't work unless the absolute value part is on the left-hand side, okay? All right, someone tell me what to do. Anastasia, tell me what to do. No. Yep, so get rid of that 3 first. So I have the absolute value of negative 4x minus 5 is less than 6. Now what? Shh. So you put it all as 1, right? So it should look like this. Negative 6 is less than negative 4x minus 5, which is less than positive 6. This is what you should be writing. Because it's an and? You do that, period. So you're setting that up as one big thing right away. Doesn't that make sense? Yeah, so go ahead and set that up right away. You know what I mean? Yeah, so you guys pay attention to this. I need you listening. Ladies, this is how you split it. You turn it into an and problem. You can separate it out, but why? Like, then you're going to get it confused with an or. So I do want you kind of like having a distinct thing to do for and a distinct thing to do for or, so you know the difference between them. This is an and, so set it up as an and full three-sided inequality statement. All right, and or are two completely separate statements with an or in between. So set them up that way just so you know the difference between them. And yes, Anastasia, I'm going to go ahead and add 5 to all the sides. So I have negative 1 is less than negative 4x, which is less than 11. Now what? Okay. Yes, why am I switching the sign? Yes. All right, so this becomes 0.25 or 1/4. We'll leave it as 1/4 just because I like fractions better. 1/4 is greater than x, which is greater than negative 2 3/4. Is that what you got? Excellent. If we wrote that the right way, it would be negative 2 3/4 is less than x, which is less than 1/4. This is what you're going to see on a test, because that's the proper way to write it. It's least to greatest. But at this point, I'll take either one. Questions on that? All right, so let's review something for a second. So for us to be able to split it, I'm going to say to apply absolute value operation. We must have the absolute value expression alone on the left, and then our inequality symbol and then a constant. That's what it needs to look like. So I'm going to give you a couple that I want you guys to do. I need to make sure that this is the order in which you have it to then be able to split it. Because from here, we split. And we need to determine if it's an and or an or from here. All right, so let me give you guys another one. Joseph? Not in Algebra 1. That might be something that you see in Algebra 2 or higher up, but not for us right now. Okay. So let me give you some to solve. I'm going to give you 2. So here's my first one. 3 times the quantity of, or 3 times the absolute value of 5m minus 6 minus 8 is less than or equal to 13. So all of you go ahead and get started on that one. You're welcome, sweetie. Thank you. So there are 2 up there. Second one is meant to kind of trick you. Not super trick you, but you need to pay attention. Somebody do that first one for me. All right, Rita, you're up. Shh. How many of you guys agree? Yeah, absolutely. Questions on that one? Okay. Let me just freeze this so I can write the second one on the next page. What was the tricky part or parts of that second one? Joseph? Oh, seriously. Ryan, what were the tricky parts?
It's no solution because it's a negative 4.
How many of you guys agree this is a no solution? Okay. I'm not saying it's not. But we're going to see, because I like what Ryan's thinking. All right, so let's start figuring this one out. What am I going to do first? Joseph?
We're going to switch sides.
You're going to do that now?
Yeah.
Okay. So I'm just going to rewrite exactly what I have here. I have negative 2 times the absolute value of 1/4 v minus 5. Why am I doing that?
Because I want the absolute value of this expression on the left side.
I do. You guys, ladies? I do want that. So I need to make sure that the bigger part of my absolute value is facing that side. So this is going to be that. Okay. At some point I have to do that. Whether you do that now or you do that in the end before you split it. At some point you have to do that. All right, Joseph, now what?
Next, I'm going to add a negative 4 to the side.
All right, so I have negative 2 times the absolute value of 1/4 times v minus 5 is greater than negative 7. I am concerned that this is a no solution. However, what do you notice is up there? That's going to throw it off that it's not a no solution. Carmen? Negative 2. So Joseph, now what? Divide each side by negative 2. So I have the absolute value of 1/4 times v minus 5 is less than 7/2. Why did I flip that symbol? Why did I flip that symbol? Carmen? Yes, that's exactly right. I have to flip that symbol. I divided by a -2. How many of you guys saw that? Okay, so here's the thing. If you missed that, then your answer would not make sense. You would have a smaller number is larger than a bigger number when you get done. You might have something like, and I'm sure this isn't exactly the answer, you might have something like -3 is greater than x, which is greater than 4. Well, that's not true. -3 is not greater than 4. So you know you did something wrong. And if you know you did your math right, then that means you didn't flip the symbol. So you really have to pay attention to that. Okay, nice catch on that, Carmen. Now what? Is this an and or is this an or? Somebody split this for me. Natalie? It's an and, so go ahead and split.
So I did -3.5 is less than 1.
Oh, dude, I'm working with fractions. Work with fractions. So -7 halves.
Yeah, -7 halves is less than 1/4 b minus 5, which is less than 7.
Excellent. So let's work with fractions. Just because. Because I'm mean.
So you add 5 to both sides.
So what's 5 going to look like with the denominator of 2? What's an improper fraction for 5 that has a denominator of 2? Rita? 10 over 2. Wouldn't that be the same thing as 10 over 2?
Yeah.
Excellent. All right.
You have 3 halves.
Yep.
Is less than 1/4 b, which is less than 7.
Excellent. You're doing awesome because I threw a loop at you. Go ahead.
And then you multiply by 4.
Yep.
And then
You're doing it on the fly. I know. You're doing a good job.
6
Yep.
is less than b, which is less than 3.
Hang on. I threw an equal to and I shouldn't have. Go ahead. So that's going to be 2. That's 0. That's 2. So that's 34. Nice job, Natalie. I threw you off. I know. So this one was trickier. So I do agree with Joseph, it was trickier. The one thing to keep in mind is do not decide if it's a no solution until you get the absolute value term completely alone. It is super easy to do that. But you have to have the absolute value completely alone, whether you decide if it's a solution or no solution. And then if it's an and or an or. Okay? Yes, Al. Yeah. Exactly. So once we get to this point, Al, we have -2 times in any absolute value. If our coefficient in any inequality, when our coefficient is negative and we have to divide by that negative number to get the variable alone, and in this case to get the absolute value alone, we have to flip the symbol. All right, so this is combining a whole bunch of stuff. Are you guys cool? Awesome. You guys can go.